I hope you're ready to find and estimate square roots today. This should take you back to looking for Pythagoras. So when we talk about a square root, we know that the number a is a square root of b if a squared equals b. So if a times itself equals b. So if I ask you what's a square root of 16, you could say, well, 4 times 4, 4 times itself is 16, so that's a square root of 16. So, for example, what number or numbers is or are the square root of 25? Think about this for a minute. If you said the number 5, that is partially right because 5 times itself does equal 5, but I'm challenging you to think of a number that multiplied by itself also equals 25. Pause the video, think about it. Okay, did you come up with -5? Because it's true that -5 times itself also equals 25. So when I ask you the numbers that are the square roots of 25, both 5 and -5 work. Okay? If a number has more than one root, its principal root is the positive root. So if I ask you for the principal root of 25, principal square root of 25, you could just say 5 in that case. Looking at a little bit of notation, if you see this square root symbol that you're pretty familiar with, that means the principal square root. So if I wrote a problem like this, I'm only looking for the principal square root of 25, so you would be right in saying just 5, the principal square root of that. If I want you to tell me the negative square root, I'm going to put a negative sign in front of it. So the negative square root symbol, that means the negative square root. Sometimes I'm looking for them both. You have this cool little plus or minus symbol. That says plus or minus, I want both square roots, the positive and the negative one. So if I gave you something like plus or minus square root 25, I'd like you to answer plus or minus 5. Okay. All right, we're going to look at some examples today, and I'm going to ask you to simplify the expressions. So this one we've done many times as our example, so that should be no problem. And if you try, I'm going to just go ahead and remove these all so you can try them on your own, and then I'll work through them. So you can try these on your own and then see if you're getting what I get. So first of all, the principal square root of 25, that's just 5. We've talked about it before. The next one asks for the plus or minus square root of 9/25. I'm asking that you try this without a calculator. It's helpful to kind of break it up into two parts. The square root of 9 on the top is 3. The square root of 25 on the bottom is 5. We know that 3/5 times 3/5 because we just multiply straight across is 9/25. I'm asking for both the positive and the negative, so here I want plus or minus 3/5. Okay, this next one is just looking for the negative square root of 64. So in this case, the square root of 64, the principal square root is 8. The negative square root of 64 is -8. -8 times -8 does give you 64. Okay, D, this is a tricky question. It says the square root of -49. So I hope you thought a little bit and asked yourself, hey, what number times itself equals -49? And you probably tried 7 times 7, but that gave you 49. Then you might have tried -7 times -7, and that gave you 49. So I hope that you came up with that this has no solution. At least as far as we know right now, there's no real number that is the square root of -49. Okay. We're going to look at whether or not things are rational or irrational. Remember that rational numbers, they can be written as a fraction. When you write them as a decimal, they either end or repeat. Irrational numbers, those go on forever without repeating, so no repeating pattern. So that's going to be good to know. Definitely make sure you know those vocab words. Okay, so no, reviewing that, this one's square root of 144, and I'm looking for the plus or minus square root of them, so I want both of the square roots. So 12 and -12 is what those are. If you look at that, that ends, so that's a rational number. Okay, look at these next two and see if you can figure them out, and then I'll come back and let you know. Okay. negative square root of 1/5. So this one, you might be saying, yeah, I don't know if I can figure that out. What's the square root of 1/5? What's the square root of 0.2? It's okay with me on this one if you go plug that into your calculator a little bit. You're going to get a number that's about like this, 0.4472 dot, dot, dot. And it fills up my whole screen. I don't see a repeating pattern in it. It does not repeat, it does not end. It is an irrational number, and this is negative, by the way, symbol in front. Okay, then if I'm looking for the square root of negative, or the negative square root of 6.25, I happen to know that 2.5 times 2.5 is 6.25, so this is negative 2.5. Hey, that one, it's nice, it ends, that's a rational number. Okay, this next one, square root of 9/16, this is a fraction, so I'm going to try using the same trick that I did on the other slide. Square root of 9 is 3, square root of 16 is 4. Yeah, 3/4 times 3/4 does equal 9/16, so that looks good. 3/4, that can be written as a fraction. If I happen to write it as a decimal, it's 0.75. It ends, so it's a rational number. If I check out the square root of 7, well, there's not a whole number times itself or an easy decimal or fraction times itself that gives you 7. You can probably want to guess it's irrational. If I checked it out on the calculator, I'm getting something like this. Keeps going on forever. That is an irrational number. Okay, so it's important to be able to distinguish between what's rational and what's irrational. All right, perfect squares, I want you to know that terminology as well. A perfect square is something that's the square of an integer. So for example, 81 is a perfect square because it's 9 times 9, or negative 9 times negative 9. It's a square of an integer, it's a perfect square. But 20 is not a perfect square because there's no integer that you can multiply by itself to give you 20. So I want you, as quickly as you can, list the first 15 positive perfect squares. So go. See if you can beat me. Okay, I already actually listed them, so good luck beating me. Okay, here they are, 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225. And if you didn't figure that out, you're just doing that by 1 times 1, 2 times 2, 3 times 3, etc. I highly recommend that you memorize these. It's going to make your life in this unit much easier. Okay, a skill that I like you to have as well is to estimate square roots. So like when I said, hey, the square root of 20, well, that's not a perfect square. I want you to be able to have some sort of an idea what that is. So I'm going to start off by just giving you a number, and I want you to figure out what 2 consecutive integers the square root of it is in between. So what 2 numbers right in a row is the square root of it in between? So the first one is 40. So I'm looking for the square root of 40. I want you to guess and check kind of what you think it's in between. I'm looking for a process like this. Well, I know that 6 times 6 is 36, so 6 is too low. And I know that 7 times 7 is 49, so 7 is too high. So this must be in between 6 and 7. Okay, and the reason being because 6 squared is 36 and 7 squared is 49, and this is in between those 2 numbers. Okay, try that one for the next few. Okay. Square root of 28.34, I want you to give me an estimate for just what 2 consecutive numbers it's in between, and then square root of 170 as well. Okay, so I hope you came up with, for 28.34, it's between 5 and 6, because 5 squared is 25, and 6 squared is 36, and this is in between. And for 170, a little bit tougher, but this type of problem you would not get a calculator on, by the way. That would make it too easy. It's between 13 and 14. 13 squared is 169 and 14 squared is 196. So this is in between those. Okay. You did this last year, at least if you were in my class for looking for Pythagoras, but I want you to also try to estimate the value of the above to the nearest tenth. Okay. So this is not a foolproof strategy by any means, but it's a good way to give you an estimate. So if I'm looking for square root of 40, and I know that 6 squared is 36 and 7 squared is 49, I usually, to get myself an estimate, I look, okay, 40 it looks like it's closer to 36 than it is to 49. You know, it's 9 away from 49, 4 away from 6. So I'm going to guess something that's closer to 6. So I better guess something that's under 6.5. And it's not like, you know, it's about twice as close. So maybe I'm going to guess about something about, twice as close, which maybe about 6.3 might be a good estimate. Because then that's 0.3 away from 6 and 0.7 away from 7. It just seems to be a kind of good estimate. And I'm just estimating right now. If I'm looking for square root of 28.34, again, you try to estimate and see if you can do that. But, so I'm looking between 25 and 36. Again, this looks like it's, only 3.34 away here. Almost 8 away here. So it's going to be definitely closer to 5 than to 6. But it's not like way, way, way closer. I'm going to guess about 5.3 again. And then the last one, since 13 squared is 169 and 14 squared is 196, this one is way, way closer. 170 is way, way closer to 169. In fact, it's so close, I might think this is probably even closer to 13.0 than it is to 13.1. Okay, so hopefully that gives you an idea of how to do some estimation. All right, using a calculator, I want to make sure that you know where the buttons are on your calculator. So if you have at least the calculator or the school-issued one, it should work similar to this. So if I ask you to find the square root of 28.34 to the nearest hundredth, and I'm asking you to use a calculator, okay, so we've got my calculator here. Let's see, hopefully you can see where that is. I'll move it a little bit. So square root button, it's right above the x squared, so I'm going to type in, to get this to work, I'll be right back. The second key, and then the x squared, that will give me a square root symbol, and then I can put in 28.34, enter it, and you can see it's about 5.323. I'm asking for hundredths, so I'm just going to that second place, the 5.32, and that's my estimate. So it's going to be about 5.32. That's how you can use a calculator for it. Okay, so again, we're going to probably use a calculator on this problem. The formula, the square root of x squared plus the quantity 3x squared, gives the length of a diagonal of a rectangular field that has a length 3 times its width, x. Find the length of the diagonal if x equals 8 feet. Try that one on your own and look and see what I do. Okay, so I'm going to plug in 8 for x. So I've got the square root of 8 squared plus 3 times 8 squared. Okay, make sure 3 times 8 is in parentheses there. Now 8 squared, I know that's 64. 3 times 8 is 24. So I'm really going to be doing 24 squared here. That's 576. Okay, so I have the square root of 64 plus 576. I definitely want to add that up together. And I get 640. So I'm finding the square root of 640. And it would probably be good to use a calculator if you want a precise answer here. So I'll go back to my calculator. And remember, it's going to be second. Oops, got to use that arrow again. Okay, forgotten that. Second square root. And I will try to get this for you so it's not messing up. Let's quit that. Okay, so second square root. I'm going to type in 640. And enter. It looks like about 25.3. I don't think it gave me a specific thing to round to, so I'll round to there. About 25.3 feet seems to be my answer. Okay. What I want you to think about tonight is what type of numbers have 2 square roots, what ones will have 1 square root, and which type of numbers will have no square roots. I hope you're ready to talk about that tomorrow. Please remind me, and enjoy the rest of your evening.